Let's talk about some topics for the upcoming chapter test. 5.5 to 6.1. Now, in general, 5.4 to 6.1. You'll see. In general, you need to know your antiderivatives. By extension, know your derivatives, right? So you need to still know that because you can't do any of this if you don't. Well, you can't do most of this if you can't know.
Like you know x n plus 1 over n plus 1.
That one, know your some of the trig ones, know some of those. Like the 6 of them. Yeah. I'll tell you this, you don't need to know the inverse trig ones though. You don't need to know like the one or u prime over x square root of x squared minus 1. You don't need to know those. I'll give you up that front. No. You need to know that. It's like you need to know that just to start the question. What's up? Which one you don't need to know is called the inverse trig. You need to know how to anti-derive a polynomial.
Oh, let's do one of those. Let's just do one problem for everything.
Let me get all the things down on one sheet. Then I could do one problem of everything. Then I could just post that smart notebook. So you need to know a polynomial antiderivative. You need to know your trig antiderivatives. You need to know the antiderivative for EX and LN, which is pretty basic. Yeah, but you need to know that because that could be in a question for these tests. Let's say that for now. I'm not thinking anything else that might. Yeah, we'll just say that. All right. So first type of problem you get is the fundamental theory of calculus. This is when you have a variable or x in the upper or lower bounds. Okay. Let me put like a bullet point there. Okay. Let me make that smaller.
What's the variable in the upper or lower bounds for?
That's a type of problem you get. We'll go over each problem at that. I just want to make sure I have to think what is needed. So we have that. Let's see. So that's one type of problem. That's underneath upper bounds, lower bounds. Now we talked about this as 6.1, but technically it's 5.4. We'll call this initial value problems. We did this yesterday, but technically it's 5.4, so I'll just put it in that order. So initial value problems. Bounded. All right. All right. This one's called finding area.
Is there going to be allowed graph calculator on the test?
No. Finding area using antiderivatives. So this is when you have a graph and you're trying to figure out the area. Usually integrals and antiderivatives are area, but this is be more particular, or you have to change halfway through. You'll see how that looks like. We'll do an example of that. Let's see. Of course, trapezoid rule. So we got the trapezoid rule. Definitely an example on that. Guaranteed. Let's see what else we got. Okay, so slope fields. In slope fields, you'll have to make a slope field. You will also have to match the slope field. So I'll give you the slope field and an equation. You can tell me which one goes with which.
It'll be like 4 options or something.
Yeah, it'll be like a multiple choice, or it's more matching, to be fair. Yeah. On the worksheet, we did that. You just say, oh, this one goes with this one, this one goes with that.
No idea what any of this is, so you do a problem.
Okay. And then the initial value problems, which you did yesterday.
No idea what that is. It's not like a thing with a bunch of a graph with a bunch of little lines on it. Just giving numbers.
All right, for now, this is what I say is going to be on a test for now, unless I forgot something and I'll tell you tomorrow. But what's up?
How do you top it again?
What?
How do you do the top one again?
Antiderivatives?
No, above that.
And then below that.
Below, oh, okay. Variables, upper and lower bounds. We're going to do one problem each, okay? All right, so let's do a variable at upper and lower bounds. We'll do two problems, one where it's just upper and it's straightforward, other one where we have to do a little chain. All right, for this one. So the dy dx equals the integral of 2 to x 5t minus 7 dt. You're going to show me what is the integral based off x. So for this one, because this is a derivative and that integral symbol is an antiderivative, they basically cancel out. So what only this integral symbol with the dt and this dy dx cancels out.
T the same as X.
In this case, inside here, yes. But
And why is it antiderivative? DT is an antiderivative. Oh, dy is it.
when you see the symbol, the integral symbol, that curly s, that means you're doing the integral, which is the antiderivative. Okay, and the dt is necessary because I'm doing an antiderivative based off t. If we get to, I don't think we'll get it, but higher level calculus, you have to be specific what variable you're using. For you guys, doesn't really matter, it just matches. Now, because they cancel out, that means you're going to have some variable x to your new equation. So it's very straightforward. This one's easy.
That's the whole problem. That's fun.
The answer is y equals 5x minus 7.
Why does it cancel out again?
They cancel out because you have a derivative, which is dy dx, and the integral, which is that curly s thing. They cancel out. But now, since you cancel it out, it's terms of the variable, which is x.
What about the two? What's the
The 2 does not matter. No matter what number was down there, it doesn't matter.
What the DT thing?
Yes.
What about the DT? Fantastic.
dt disappears to become x.
Because that's X. All right, so that's gonna be the first question on this test.
Yeah, that's the freebie. If you are breathing, then you should get that right. So you just plug in x. Is that it? No, it goes away. You just plug in x.
It's like one of those transverse.
All right, now the one that actually kind of has to do some math. So dy dx of the integral, let's do a lower bound one. Let's say 2x 7 3t plus 2 dt. What's up? This is variables in upper and lower bounds, which would fall under, like, if you look at it in a book, fundamental rule calculus, okay?
3x plus 2 equals y.
Exactly.
So there's two things that's going on. First off, you need your integral, you need your variable to be on the upper limit. It is not in the upper limit. So you need to flip your integral. When you flip your integral, what happens to the overall integral? Good, it becomes negative. So what you're gonna first do is rewrite it as a negative. The integral of 2x 7 3t plus 2 3t plus 2 dt.
I hate T's because it messes up. But
That's why you got to put a little curl on the bottom. Then, now we have 2x. It's not exactly x. And that kind of sucks. So what we're going to have to do is multiply it by its derivative. We showed this with du dx, but that's like a bigger way just to say, multiply by the derivative of the top. What's the derivative of 2x? 2. So you're multiplying this by 2. And that's gonna be on your final answer. So let me just move that there.
multiplying it by 2.
Yeah, because it's 2x. So you multiply it by its derivative, which you could say you're doing it by the du dx, which in this case, if u is 2x, the du dx is 2.
If you feel
Because like, if you multiply by 2, then it's 4x. No? Aren't you multiplying
Yep.
by the?
So it's gonna be this right here. This is negative. This has become the x's now. 3x plus 2. Let's put it on the top of the page for you. 3x plus 2 times the derivative of that x you had up there, which is just 2. You do a little bit of algebra, distribute some stuff. Y equals, what's up?
It was just an x without the.
Yeah, you would not need the derivative. Or you could think of it, if it was just x, the derivative of just x is 1, so it doesn't change anything. So you do a little bit of algebra here. Negative 6x minus 4.
Where'd you get the negative 3x plus 2?
This 3t plus 2 becomes 3x plus 2.
After you multiply it by the dy dx, right?
Yes, basically. After you cancel it out, to be fair. And then I just distribute the negative and the 2 and make it negative 6x plus minus 4. Okay, let's do another one where we have both on the top and the bottom. And how do we deal with that? Dy dx equals the integral. Let's do x squared and on top. Doesn't matter, 6x, I guess. Let's just do that.
Does it matter where the variable is now?
Hmm?
Does it matter where the variable is now?
What do you mean?
Top or bottom?
And an x on the bottom, but we need them to be on the top. So you see what we're gonna do. We need a variable on top, but we can't deal, when there's a number on the bottom, we don't care. But there's a variable on the bottom, so we gotta do something special about that. Okay? So sine t dt. All right. So my issue is I have a variable on the top, which is good, but I have a variable on the bottom, which is not good. Flipping it over doesn't fix that because then now the top one will be on the bottom. You saw the variable. So what we're going to have to do is use an integral rule that we learned a while back, which was if you know, and I'll just show the rule in general. So you have some xy, you have some curve. If you have this area over here in red, and you have this area over here in green, if I just wanted this area in between red and green, I would take red and subtract it from the green. Now, what does that mean in terms of us? We're going to take this one, which is our upper bound, and split it into 6x. You could put anything on the bottom, so you put 0, let's say. Sine t dt. And we're going to subtract it. We're going to subtract it with our bottom term or our smaller bound, which is x squared. X squared over 0. These numbers should match, but remember, the numbers doesn't matter. So you put 0, 0 on the bottom, 1, 1 on the bottom. Doesn't really matter. Sine t dt. Now we have a nice split where the variable's on top, some constant values on bottom. So what we can do is just derive the top and the bottom, or use the antiderivative, cancel it out. But don't forget, these are actually not just 6. So you're going to have to multiply by those derivatives. So on the left, I will have sine of x times the derivative of 6x, which is just 6, minus, you have to take the derivative of 6x.
No, why do you not put 6x in the sign?
Because what happens in the long way is that you turn this into a u, and then you're going to have to times it by the du dx of it, or the derivative, which is just 6. So technically you're plugging in u. Oh, is it actually 6x in the middle?
Six sine x.
Check it out. It's probably actually 6x. That makes sense. So it should be whatever's here, my bad. So 6x times 6. Thank you for catching that. No, you just plug in what's here, that's all. So in
You
here,
have to plug in yeah.
yeah. And in here, you're plugging into x squared as is, but you got to multiply by the derivative. So then it should be 2x inside instead of just, I think it was just x, right? So I messed that up. I'll fix that answer right here. The blue is going to be a derivative of 2x or x squared, my bad. You're doing an antiderivative. It's just bring down to 2 and then reduce it by 1. Yeah, you gotta, yeah. So this will rewrite this correctly. 6 sine 6x minus 2x sine x squared. Technically, the 2x1 should be in front, but who cares? And then I'm going to scroll back up. I'll leave you, you copy this, and I'll scroll back up to the previous one. I'll fix that. There's, have your old test.
Is that the answer?
Yeah, that is the answer. And previously, the previous problem. Yeah, so this x, it shouldn't be just x. It should be a 2x. Which when you do the algebra, that'll be instead of 6, it'll be 12. So my fault on that. Instead of plugging in x, you should be plugging in 2x. So it just makes the algebra a little different. That's my fault. I would have lost a point for that. 12x, yeah. When you distribute everything.
You post these online.
That's why I'm doing a new notebook, so then I can just post that. We're going to continue this tomorrow. I don't know if we're going to finish all the topics, but we'll just continue this tomorrow. You got it down, Max?
Yeah, I'm good.
Everyone got it down? All right. So our next topic. What did you not say yeah? Or maybe I'm wrong. All right. We'll talk about initial value problems, which we did yesterday. I'll just talk about it today. Which one are you missing? Okay, cool. All right. Initial value problems. This is where you need to know your antiderivatives. You can't do it without antiderivative skills. But you have some antiderivative or integral. I should be saying integral. Let's say it's 3x squared plus 10 dx. And you know it's at some point where x equals 2 and y equals 0. So you'll be given that, and you're going to give it a coordinate point. It can look like that. It could technically also look like this. F of 2 equals 0. That's the same thing. So for initial value problems, you got 2 steps to it. 1, we just got to do the antiderivative. And 2, we need to find the C value. And actually, I have to say this. Technically, it shouldn't look like this. It'll look like you'll be given it like this. My bad. Dy dx equals this. It'll be given to you looking like this. So this, what you're given, is the derivative. We want the original equation, so we have to do the antiderivative to it. So what you're doing is you're going to antiderive this. So this y is going to equal the integral of 3x squared plus 10 dx. That's why I put that first, because I was doing the work already. But you will get your problem look like that on top. But your first step will be making that integral out of it. And very important, this is an indefinite integral, no upper or lower bounds. So we need to make sure we put a plus c at the end. And that plus c is important because that finishes off the problem anyway. So the antiderivative of this, 2 gets bumped up to 3, then you divide it by 3, but that cancels out, so it's just x cubed. When you have a constant, 10, it is going to go up to 10x. You could think of it as x is 0 power 2. Or you can think of it as, I know the derivative of 10x would give me 10.
Plus C.
And then you got to put your plus C. Don't forget that. No matter what your antiderivative was, it's plus C. Even if it's trig, even if it's e at x, you got to put that plus C. But I need to find this plus C. But luckily for me, I actually have some coordinate points. And that's why I compare it to mx plus b. You remember that from algebra 1? You have your coordinate points and you have your m. So then you do your work to find b.
0 equals
Go ahead. 0 equals.
AB plus 20, 28.
Good. I'll just plug it in like this though. 2x plus
Negative 28, so y equals x cubed plus 10x minus 20.
plus c. So that's 8 plus 20 plus c equals 0. Little bit of algebra here. Negative 28 equals c. That value is important, but I need that final equation. So that final equation is y equals x cubed plus 10x minus 28.
That's good, man.
Yeah, this straight feels back to normal, just algebra after you just do one antiderivative. Yeah. I have a recording of this and I'll post it too.
Of course, Tommy.
Also, we're not gonna do all the topics today. I just see how many topics we have. We'll continue this tomorrow, okay? All right. Let's go to the next topic, which is finding the area. So I'm gonna be giving you a graph in this sense. And I'll make a purposeful graph here. And you need to know how to do the antiderivatives for what pieces. So I'm going to make a very particular graph. Let's see. Let's say this is going to look like this. And so it's straight when you get up there and then curves. So we're going to say this is. So this part of the equation is going to be y equals 2x. And then this part of the equation is going to be y equals negative x squared. Wait a second, let me think. I need this to be 4 at 2. Two comma 4, that'd be correct. No, that'd be negative 4. No, no, I can't really make these up because this has to be a particular graph. That's what makes it hard. So I'll just do it like this. 3, 4. So we'll just make this y equals x squared. Okay. And I want the area underneath the curve here, so. I want that green shaded. Okay, that works.
That's the question.
Yeah, so this, whatever this function is, which is like a piecewise function, basically, from, we'll say 0 to 4. Okay. Yeah, it's a weird graph. And there's different ways to make the graph weird. So I'll try to go over that more in detail with like computer-based ones or like textbook ones. So this one is effectively, you got a piecewise function. I need to make integrals with different pieces. So I have from here to here, from 0 to 2, if I made my 2 a little better, from 0 to 2, I'm using one particular type of equation. What equation is it? It does look like a triangle, and you could use a triangle actually. But I know it's going to be, I'll just write it like this first off. The integral from 0 to 2 for this part of the equation, 2x dx. And Maya hit something important. Hey, I could do this geometrically if I wanted to. You could do it like that. If you did an antiderivative, you'll still get the same answer. Because from 0 to 2 is the x values. And the equation, I have to give you that red equation to the question. So it's y equals 2x. For that piece from 0 to 2, it follows the rule y equals 2x. But you have this other additional piece. What rule is it following here? X squared, which we're going to do the antiderivative or integral between what two numbers? 2 to 4. So x squared dx. So in these type of questions, it's just testing on you know what parts to break it up into and then antiderivative. No, you would do the math. You do the antiderivative of all that.
Of all that?
Yeah, sure. We'll just finish it off with this one. So 0 to 2, again, this is a triangle on the left, so you could just do base times height divided by 2. I'll do the antiderivative just derivative. So for the first one, I'll do in blue. It'll be the antiderivative of this, which is 2x squared divided by 2. Cancel that out, it's just x squared. X squared from 2 to 0, which is going to be 2 squared minus 0 squared, which is 4. So this piece right here is 4, and you could have done that with a triangle. Yeah.
You plug into it, that was coincidence.
It is 2 because you stop at 2. Oh, in the original one, yeah, it's a coincidence. You up the power when you do an antiderivative, so it's x to the 1 to the x to the second, then you divide it by the new power. And then the second part, I'll do that in green over here. This will be a little bit more involved. This was x to the second. So I got to up the power now, so that's x to the third. So this is x to the third over 3 from the difference of 4 and 2. So 4 to the third power over 3 minus 2 to the third power over 3. 4 to the third power is 4, 16, 64.
4 cubed times 1/3.
You can do it like that too. Minus 2/3 is 8 over the third power.
Well, I guess it's easier with the fractions.
I think it's, yeah.
It's the same.
No, it's exactly the same because you just put it divided by 3. Yeah.
56 divided by 3.
64 minus 8 is 56 divided by 3. That's not clean, so you could leave it as 56 extra. Actually, you don't because you want to add it to 4.
Yeah,
So what I'm going to do, so that's that, right? So then I'll just combine the two things. 4 could become 12 over 3 plus my 56 over 3. This is going to be 68 over 3. Can that be simplified? No, it's 14, right, when it adds up. So you could leave it as 68 over 3. You're just doing 2 antiderivatives. Basically, you're doing how many antiderivatives you split it up to.
So